Good afternoon, all. Write your name and seat number in the chat box. Today, we are going to start the chapter number 8, elements of group first and 2. These group first and 2 elements are also called as S block elements because the valence electron enters in S subshell for this group 1 and group 2 elements. In group 1 elements, there is only one electron in the valence shell, and in group 2 elements, there are two electrons in the valence shell. It is having the weightage 4 marks and with option 6 marks. So this is the note. This is the reduced syllabus. Already the PDF is sent to you of the reduced syllabus. Today, after finishing this lecture, I will send the PDF copy. I think the PDF copy of this chapter is also sent to you. Chapter number 8 and chapter number 9 is also sent to you. Only one chapter's PDF is remaining, that is chapter number 5, chemical bonding. That PDF also today I will send. Also, I will send today the PDF copy of adsorption and colloids. So, check how many chapters are completed. Chapter number, we started the 11th standard from chapter number 14, that is basic principles of organic chemistry. The name of the chapters, I think, not given in this slide. So I will show. If the textbook is there in front of you, I will tell you which chapters are completed. Chapter number 14 is completed, 15 is completed, that is hydrocarbons is completed. Then chemistry in everyday life, chapter number 16. Then chapter number 1, basic concepts of chemistry is completed. Introduction to the analytical chemistry, chapter number 2. Chapter number 3, chapter number 4, structure of atom is completed. Then chapter number 6, redox reaction is completed. Then chapter number 7, modern periodic table is completed. And today this chapter is started because it is related to the periodic table. Now, the structure of atom and the periodic table, these are related to the chapter 1 and 2. So it will be very easy for you to understand this chapter. And after this chapter, we will complete the elements of group 13, 14, and 15, that is P block elements. Then we will discuss the chemical bonding, that is chapter number 5. It is one of the biggest chapter in chemistry. It is having 8 marks weightage, and with option it is 6 marks. So this chemical bonding we will take in detail. After the chemical bonding, we will take the adsorption and colloids. Last two chapters, that is nuclear chemistry and states of atom. States of matter. I will give the questions on this chapter because it is having the very small weightage. So in the next 2 weeks, we will complete our syllabus. So note, this is the deleted syllabus. The entire hydrogen part is deleted. Then the biological importance of the. I already make the deleted mark on the slides, which part is deleted. So don't worry about the deleted syllabus. Members of S block elements. So already I discussed these group 1 and group 2 elements are present in S block elements. In group 1 elements, these are also called as alkali metals. The name is shown here, alkali metals. All these are metals: lithium, sodium, potassium, rubidium, cesium, and francium. These are the names of group 1 element. And in group 2 elements, these are called as alkaline earth metals. Both group 1 and group 2 comprises the S block elements because the last electron, valence electron, enters in S subshell. Remember, now you are very familiar with the shell, subshell, orbital, shapes of orbital, quantum numbers. You are having the brief idea about all these things. So in group 2 elements, it starts from beryllium, magnesium, calcium, strontium, barium and radium. This is beryllium and this is barium, remember, and this is the radium. This is a radioactive element. So one by one, we will discuss the group 1 elements and then we will discuss the group 2 elements. So this is a general introduction about the S block elements. It is given S block elements are placed the left hand side of the periodic table. If you see the periodic table, you will find these are kept extreme left hand side. Subshells or orbitals are filled according to the increasing order. These block elements contain mainly two groups, group 1 and group 2. Group 1 elements having only one electron and group 2 elements having the two electrons in the valence shell. Group 1 elements are called as alkali metals and group 2 elements are called as alkaline earth metals. Now, why these group 1 elements are called as alkali metals, I will explain. It is also uh, highlighted with this bold, with this red color, because these metals form oxides. Whatever the metals given in group 1 elements, these metals form oxides and hydroxides, which combine with water to form alkali. That's why these elements are called as alkali metals. And alkali, actually, this is Arabic word. Alquiz means plant ashes, which are rich in carbonates of sodium and potassium. So this is the connection with the word alkali. Then already I discussed these metals are present. Hydrogen actually uh, is not a metal, but since it is outermost electronic configuration having the only one electron, that's why it is included in group 1 elements. So this is exception. Hydrogen is exception. Though it is not a metal, it is included in group 1 elements because of the electronic configuration. Z is 1, atomic numbers are given in bracket. Lithium, Z is equal to 3, sodium 11, potassium is 19, rubidium is 37, cesium and francium. So how to remember these metals? One short form, remember one short form I have prepared for to remember these metals. Helena, that is Helena, H for hydrogen, Li for lithium, Na for sodium, Cabrase Ferrar, K for potassium, Cabrase RB, it is for rubidium, and Cabrase say for cesium and Ferrar for francium. So this is a short form I have prepared to remember these group 1 elements, and group 2 elements also I have prepared one short form. Beryllium, that is beta, Be, see the elements beta, mange, car, scooter, baproe. So beta, that is for beryllium, mange, magnesium, car, calcium, scooter, that is for strontium, bap, Ba, barium, roic, that is for radium. So by using these tricks, we can remember all these group 1 and group 2 elements. Its electronic configuration is also given in the bracket. Uh, the group 2 elements are called as alkaline earth metals because they occur as minerals in rocks. They are found in rocks. That's why these are called as alkaline earth metals. The elements magnesium and calcium. See, it is given magnesium having the atomic number is 12, calcium having the atomic number is 20. These found abundantly in the earth crust. Its percentage is more in the earth crust, but the last element, radium, it is a radioactive. It is not very easy to found. This radium and polonium, these are the radioactive elements discovered by the scientist Madame Curie. So radium is the first radioactive element which is discovered by the scientist Marie Curie, or it is also known as Madame Curie. And the second one is polonium, but this is not present in group 1 elements, remember. Only the radium is present in group 1 elements. So this is the brief introduction about the group 1 and group 2 elements. So the electronic configuration is actually the similar electronic configuration. The general outer electronic configuration we can see here, it is only one electron in the valence shell. So it is ns1, where the n stands for the principal quantum number 1, 2, 3, 4, like this. See here, 1, 2. In case of hydrogen, it is 1s1. In case of lithium, we can see here, I will show with the help of pen. See here, it is 1s1. Then for lithium, it is 2s1, then 3s1, then 4s1, then for rubidium it is 5s1, then 6s1, and then 7s1. So the general electronic configuration we can write for the group 1 element, it is ns1, and similarly for the group 2 elements it is ns2. For the group 2 elements it is ns2, remember. So it is very easy to remember the general electronic configuration. From this table we can get the brief idea about the condensed electronic configuration. I discussed this condensed electronic configuration in the previous chapter. Uh, the structure of atom, how to write the condensed electronic configuration. In case of condensed electronic configuration, we have to check the nearest inert gas. So from lithium, we can start the condensed electronic configuration. To lithium having the atomic number 3, whose nearest gas is helium. So this helium we have to put in bracket, helium atomic number is 2. So it will be 2 and 2s1. After this helium, the electron enters in 2s1. So this is a condensed electronic configuration of lithium. This is a sodium. This is potassium, rubidium, cesium, and francium. See, we can clearly see the inert gases are kept in bracket. Helium, neon is having the atomic number 10, argon is 18, then krypton is 36, and this is 54, and this is 86. So these are the atomic numbers. This is the condensed electronic configuration, and this is the detailed electronic configuration is given. So you must know the electronic configuration. From this electronic configuration, one thing is clear, only one electron it is present in the valence shell. And if this electron is given, because this electron, see, in case of lithium, if this electron is given, they become stable. If this electron is given, they become stable. So these group 1 elements, they easily gives these electrons because they want stability. For the stability purpose, they easily donate electrons and form the compounds. So they forms M plus ions. M plus ion means when one electron is given, they becomes M plus. Therefore, alkali metals or these alkali elements never found in free state in nature. Why these do not found in free state in nature? Because this one electron can be easily given and they can combine with another atoms of elements and form compounds. So because of this one electron, they do not found free state in nature. Lithium, sodium, potassium, these are the values. So these are the pictures given: lithium, sodium, potassium, how the lithium looks, sodium, potassium, rubidium, and cesium. These are the pictures shown for your curiosity, how lithium looks, sodium, potassium, rubidium, and cesium. Then physical properties of these group 1 elements, alkali metals, we can see with these diagrams. These are silvery white colored. These are very soft and light metals. Because of the large size, these elements shows low density, which increases from down the group. Density increases from down the group, that is from lithium to cesium. However, potassium is lighter than sodium, remember. The melting and boiling point of these alkali metals are low, which indicates weak metallic bonding due to presence of only one single electron it is present in them. The alkali metals and their salts having the characteristics color to an oxidizing flame. This is because the heat from the flame excites the outermost electron which is present in that orbital to the higher energy. This explanation is given why these salts having the color. This is because when the heat is supplied to these oxides, what happens? The last electron which is present, which gets excited, and when the excited electron comes back to the ground state, there is emission of radiations. So due to this emission of radiations in the visible region, the spectrum is given below. See, this spectrum is given below. Actually, the question it is asked for the JEE NEET exam and the CET on this. Remember this question on this flames always ask for the NEET, JEE and CET exam. So concentrate here. The metals are given lithium, sodium, potassium, rubidium and cesium. These colors are given crimson red, sodium having the yellow color, potassium having the violet color, rubidium having the red violet color, and cesium having the blue color. So these colors are asked for the NEET, JEE, and CET examinations. Remember, for the board examination, no any question will be asked on the color and the values. But for the competitive examination, these flame colors are very important. Lithium, many times it is asked what is the color of lithium flame. So remember, and these wavelengths are given below, and these are the colors. So alkali metals can therefore can be detected by the respective flame test. So flame test is a very useful method to detect the metals. The flame test can be determined by the flame photometry or atomic absorption spectroscopy. These are the instruments used to detect the flame test, which are not, this practical is not included for 11th standard, 12th standard, but these apparatus are very costly. Flame photometry, then atomic absorption spectroscopy. These are the very costly instruments. For the PG level, we can do this test or we can see this apparatus. Also, you can check on Google what is the functioning of flame photometry, atomic absorption spectroscopy. We can also check on Google. These elements, when irradiated with light, the light energy is absorbed, may be sufficient to make an atom to lose electron. So this property makes cesium and potassium useful as a electrodes in photoelectric cells. So which property? Because when these elements are radiated with light, when the light is actually when the light is passed through these elements, or light is passed on these elements, what happen? They absorb the light energy, and whatever the outermost electron is there, it can be excited. So this property, it is useful for the cesium and potassium to make electrodes in photoelectric cells. So remember, this can be also asked for the MCQ purpose for the competitive examination. Cesium and potassium. Physical, no any question will be asked on physical properties for the board examination. Remember, HSC board examination, no any question it is asked on physical property. This is only for your information, and for the competitive examination, this is very important. The color of the flames and why these metals are soft. Then next part is atomic and ionic radii. Already we discussed about these atomic and ionic radii in the entire periodic table. They have the largest site in these respective periods. Remember, they are having the largest size in their respective periods of the periodic table. Atomic and ionic radii increases with atomic number. As we move from lithium to cesium, the electron is entered in new shell, so atomic size is increases. And what about the ionic radii? They forms the monovalent ions, that is M plus. When one electron is given, they easily forms monovalent ions. These are smaller than the parent atoms. Which is obviously true, because when one electron is given or one electron is donated, uh, there is a contraction in atomic size, because entirely the shell will be, if suppose we take the example of lithium here, I will show. See, if we take the example of lithium 1s2 to s1, if the one electron is removed, so this entire 2s shell will be removed. So the atomic size will be decreases. Means atomic size of the monovalent ion is less than the parent atoms, because this complete entire shell will be removed, because if this one electron is given. So it is mentioned here Monovalent ions are smaller than the parent atoms. See, one example is given here. Atomic size of lithium is 152 picometer. And what about the Li plus? It is C 76, means it is almost half. It is almost half. Lithium plus is almost half because one electron is removed. So this is about the atomic and ionic radii from top to bottom. Then I'm coming to the ionization energy. Uh, ionization energy, you know the definition of ionization energy: amount of energy required to remove most loosely bound electron from the gaseous state. Always these ionization energy values are positive. We discuss these details in the chapter modern periodic table. So ionization energy, these are exactly opposite to the atomic and ionic size. When the atomic size is increasing from to bottom, so ionization energy values always decreases, because as electron goes away from the nucleus, it is very easy to remove. But if the electron is closer to the nucleus, that is in case of lithium, it will be closer. So ionization value of lithium, it will be more than the ionization energy value of the cesium. It will be less, because in case of cesium, the valence electron is away from the nucleus, we can easily remove it, means less amount of energy is required to remove the electron which is present in the outermost orbital of cesium. But in case of lithium, it will be closer, so ionization energy will be more. As we move from top to bottom, these values will be decreases because electron is go away from the nucleus. All these factors are already discussed: atomic size, nuclear charge, and screening effect. We know. We can also see here in this table. See, the atomic number is also increasing. Atomic mass. See, atomic mass is also increasing. Electronic configuration is given. Ionization energy. We can check here. Ionization energy. See, the highest amount of energy is required for remove the electron in case of lithium, and see the ionization energy for the francium is only 375 kilojoule per mole. Then ionic radius we can see here is increasing. Atomic size is also increasing. Melting and boiling points are given here. Density is also given. No any question it is actually asked on these values. So these values are given for only for understanding purpose, to explanation of ionic size, explanation of ionization energy values. So never these values are asked for the examinations, for the CET examination also, for the JE examination also, for the NEET examination, and for the board examination. No any values are asked on this table. So this table is only for your understanding purpose, only for your knowledge purpose. Then we will start the chemical properties of alkali metals. The alkali metals are highly reactive. I want to ask one question to you. I have unmuted all. I want to ask one question. 30 students are there. Avishkar? Avishkar, unmute yourself and tell me, am I audible clearly? आता अनम्यूट करा.
येस सर.
असं इथे
येस सर, अनम्यूट होत नव्हतं मागाशी.
कळलं ते मला. One sentence is written here: the alkali metals are highly reactive. Anyone can tell me why these are highly reactive?
सर ते त्यांच्या आउटर मोस्ट शेल मध्ये एकच इलेक्ट्रॉन असल्यामुळे त्यांना एक
Very good.
इलेक्ट्रॉन लागतो कम्प्लीट करण्यासाठी.
व्हेरी गुड, व्हेरी गुड. दॅट्स वाय दे आर रिॲक्टिव्ह. म्हणजे काय करतात ते, वन इलेक्ट्रॉन दे ऑलवेज ट्राय टू डोनेट, सो दे विल गेट द स्टॅबिलिटी. So these are very, very highly reactive in the periodic table. Remember, alkali metals are highly reactive in the periodic table because of only one electron in their valence shell. So they want to complete their shell. So for completing, they will easily combine with any other element. So they have larger size and low ionization energy. Low ionization energy means very easily these electrons can be removed. So, but the chemical reactivity increases from top to bottom. Chemical reactivity increases from top to bottom, lithium to cesium. See the reaction with oxygen. What will happen to the oxygen or air? The alkali metals become tarnish. Tarnish means they lose their brightness actually in dry air. Why this is happening? This is due to the formation of their oxides. They easily get oxides. Means when they kept long time in a year, their they loses their tarnish. Means the whatever the brightness they are having, they lose their brightness. So we can check this experiment with sodium, because sodium always kept under kerosene because of this reason, because they easily gets oxidized. As they easily gets oxidized, this sodium, it is always kept under kerosene. This is due to the formation of their oxides, which again react with moisture to form hydroxides. When these oxides reacts with water, they becomes hydroxides. So lithium forms uh, monoxide, Li2O. Such type of monoxide it is formed by lithium. Sodium forms peroxide, and other alkali metals form superoxides. So in case of group 1 element, there are three types of oxides. First one is monoxide, superoxide, uh, CEL. Lithium forms monoxide, sodium forms peroxide, and other alkali metals form superoxide. So there are three types of oxides, remember, and the reactions are given here. See, lithium forms lithium oxide here, and sodium forms peroxide, NO2, Na2O2, and this M for other alkali metals. They for potassium, rubidium, cesium, and uh, francium. This is radioactive, which chemistry is not very much known, so it is not mentioned here. MO2, this is a superoxide. So these oxides are strongly basic in nature. They dissolve in water to form the uh, hydroxide, and which are the strong alkali. NaOH and KOH, all these are very strong alkali. One example is given here. LiO plus lithium oxide, when it is reacts with water, they forms the LiOH. All these are alkalis. LiOH, KOH, then NaOH, all these are alkalis. So these reactions can be asked for your examination, but due to the COVID situation, there is no examination. But whenever examination is there, always the question it will be asked on this topic. Then reaction with water. Alkali metals are highly reactive. They react with water to form corresponding hydroxides. Corresponding hydroxides. So when react with air, they form oxides. When they react with water, they form hydroxides, and they evolve hydrogen, dihydrogen, H2. It is H2 gas is removed. See, we can make arrow like this because it goes in the air because it is lighter than air. Except lithium, all the alkali metals react explosively with water. Remember this. Explosively. Explosively, they react with water, except lithium. Lithium, because we considered reactivity increases from top to bottom. So lithium is, as compared to the other elements, lithium is quite less reactive. Other elements are, other metals are highly reactive. Explosively, they react with water. Then, because of this hydrogen, they undergoes explosion, because hydrogen is very explosive gas. This is another reason to kept sodium under kerosene, because if sodium is came in contact with any moisture, it will be catches fire. Remember, so we have to take precaution to preserve these elements, group 1 elements. These are reactive.
सर सीईटी बेस कुठले क्वेश्चन येणार आहेत सर?
हे कुणी जगात सांगू शकेल का आपल्याला? सीईटी वर कुठलाही क्वेश्चन विचारू शकतो. Whatever the syllabus is there on 11th standard, 12th standard, they can frame any question. Whatever.
येस सर.
हा, ते कुणी तुम्हाला सांगू शकणार नाही कुठला क्वेश्चन येईल. Whatever the syllabus is given for HSC 11th standard, तुमची जी सीईटी असेल ती वेगळी असणार आहे, त्याचा सिलेबस वेगळा असणार आहे. बिकॉज already I discuss about this syllabus and whatever the question paper pattern, it will be decided later after completion of your 12th standard. Your syllabus will be decided. So
येस सर.
don't make
ओके
haste
सर.
for that. I will intimate about the syllabus and question paper pattern, because you know I am the member of that CET committee for chemistry. So don't worry, I will give the update. Then the next one is reactivity of the reactivity. Again, I will mute all. Reactivity towards hydrogen. Reactivity towards hydrogen when these alkali metals reacts with dry hydrogen. Remember, hydrogen should be dry. There should not be any moisture, should not be present in hydrogen. So hydrogen should be dry. When they reacts with dry hydrogen at high temperature to form corresponding hydrides will be formed. The stability, these hydrides will be decreases from lithium to the cesium. So lithium forms lithium hydride, sodium forms sodium hydride, potassium forms potassium hydride, then rubidium form rubidium hydride. So the stability of these hydrides decreases from lithium to cesium. Beside these hydrides, lithium and sodium form the complex hydrides. These hydrides are very important. These hydrides are very important. Hydrides of lithium and sodium. These are lithium aluminum hydride and sodium forms sodium borohydride. These are used as a reducing agents. These are very important. Remember these names. Lithium aluminum hydride, because in 11th standard and 12th standard we have to use this reagent. It is called as LAH. This is a short form of lithium aluminum hydride and sodium borohydride, which are the powerful reducing agent widely used in organic chemistry. So these are the complex hydrides. Remember, detail of this lithium and borohydride and sodium borohydride we will discuss in 12th standard in detail. But the other alkali metals, they forms only these hydrides. So general reaction is shown here. 2m plus H2, the temperature is given. The hydrogen should be dry. Twice m plus and H minus. These kinds of hydrides it will be formed. Then the next part is reactivity towards halogens. All the alkali metals reacts vigorously with halogens to form their respective ionic crystalline halides having the general formula M plus X minus, where M is the alkali metal. So these are the typical types of halides it will be formed.
येस सर.
Next part is reducing nature. Reducing nature of alkali metals. All these are chemical properties we are discussing. The reducing power of the element, it is measured in terms of standard electrode potential. Actually, this part, it is included in the chapter redox reaction, and I told you to read this standard electrode potential values, which are one table is given on the last page of this redox reaction chapter. In this redox reaction chapter, one table is given. In that table, the standard electrode potential value, that is denoted with E naught. That is denoted with E naught. So The reducing power of the element, it is measured in terms of standard electrode potential corresponding to the transformation. This is a metal, and this is a when one electron is removed, they forms monovalent ions. So all the alkali metals having the high negative values of standard electrode potential. So it is an indication of their strong reducing nature. Remember, all the standard electrode potential values of these alkali metals are negative, and these are very highly negative. So this is the indication, these values are the indication of their strong reducing nature. So lithium is the most powerful and sodium is the least powerful in that group. We can see also the table. In this table also these values are given, standard potential values we can see here. We can see the values are given here, standard potential values are given here. Is lithium minus 3.04, sodium, see these all the values are given here. So see the values of lithium is more, see the value of this is sodium, see the value of potassium, rubidium, cesium, all these values are standard electrode potential values. So according to these values, lithium is the most powerful and sodium is the least powerful. Then next chemical properties. Solutions in liquid ammonia. What is the reaction with liquid? So the alkali metals dissolve in liquid ammonia, giving deep blue solutions, which are conducting in nature. So this is general reaction which is given. This is the metal X plus Y ammonia. They forms such type of complexes. The general complexes are given. So the blue color of the solution is due to the ammoniated electron which absorbs the energy. See why the blue color is there, because this is the ammoniated electron, means when they react with ammonia, this electron which absorbs the energy in the visible region of light and thus gives blue color to the solution. The solutions are also paramagnetic and on standing slowly liberate hydrogen, resulting the formation of amide. So here amide formation is given here, and this is the blue colored solution it is given. So where Am